In today's Python video, we're going to be covering the Mann-Whitney U test. We're going to cover when you want to use this specific test and then go over a few different examples, including a manual calculation and then a shortcut with the help of SciPy. So with this intro out of the way, let's go over a little bit more information about the Mann-Whitney U. All right, so some more information on the Mann-Whitney U test. So this is also known as the Wilcoxon rank sum test. Also see it out there as the Mann-Whitney Wilcoxon. There's also a few other variants, but the most popular way I see this mentioned is Mann-Whitney U. It's a non-parametric alternative to the independent unpaired t-test. Use the alternative to the t-test when the assumption of normality is not met, since it's more robust against outliers and suitable for non-normal distributions. Essentially what this does is it looks at the rank sum difference, whether one distribution tends to have higher or lower values than the other. And one way that we can also test for normality is the Shapiro-Wilk, which I've covered here on the channel. We'll jump into some of the Python code by using Shapiro-Wilk, but not with these slides. And also to mention, you can still run the test even if the data is normally distributed, although it's not necessary. Let's talk about the rank sum difference. So the Mann-Whitney U relies on rank sums, meaning it compares the ranks and values rather than the values themselves. So there's 3 steps associated with it. So combine the data from both groups and rank them from smallest to largest, sum the ranks for each group separately, and calculate the U statistic, which is based on the differences in these rank sums. So let's take a look at basic example, group A, B, right, 5, 8, 6, 7, 3, 9. So combine these, right, 3, 5, 6, 7, 8, 9, 5 and 6 group A receive 2 and 3 rankings, whereas 7 receive ranking 4. Then you just sum them, right? So group A, 2, 3, and 5, 10. Group B, 1, 4, and 6, you get 11. So that's how rank sum works. We'll cover it in more detail a little bit later. So the null hypothesis, there is no difference in the distribution of ranks between the 2 groups. The alternative hypothesis, the distribution of ranks between the groups differ. There are 2 types of alternative hypothesis. You have the two-tailed, the distributions are not equal, and then you have one-tailed. Either say it's consistently higher or lower depending on the tail direction. So let's take a look at an example, right? So imagine we have 2 sports card shops, store X and store Y. Both stores want to compare customer satisfaction scores to see if one has higher satisfaction than the other. We can skip the Shapiro-Wilk in this case, and I'm going to say the alpha is going to be 0.05, right? So here's the satisfaction scores for X, 82, 85, 87, 88, and 90, and then Y, 84, 86, 89, 91, and 92. So combine all the scores from both stores, then rank them smallest to largest. There's the tie, we'll have an average rank. So here's the scores, right? So you have 82 through 92. Here's the ranks associated with them. Okay, 1 through 10. So store X has ranks 1, 3, 5, 6, 8. Store Y has 2, 4, 7, 9, and 10. Then we need to calculate the rank sums. So just sum these up. X has 23, Y has 32. Now what we're going to do is we're going to follow this formula to the top right. So we're going to add in the values for X and then add in the values of Y. Now NX and NY are going to be 5 apiece. Our X is 23, our Y is 32. So you just plug these in, you get UX equal to 17, UY equals to 8. The Mann-Whitney U statistic is the smaller of UX and UY, so you get a value of 8. And then the p-value from this is going to be 0.42. And we would not reject the null hypothesis at this significance level because we're looking at alpha 0.05. Suggests there's no statistically significant difference between the scores between store X and store Y based off the Mann-Whitney U test. So we're going to jump into a lot of examples in Python, one manual, and then I'll show you a bunch of shortcuts with SciPy. But yeah, the background information is out of the way, and make sure to grab your notebook. And let's start coding. All right, so let's get started. What we're going to do, we're going to import in NumPy as NP. I will import pandas as PD. Coming in from SciPy.stats, we're going to import in our Mann-Whitney U and also our Shapiro. And once we have those, what we're going to do next is we're going to set our alpha value. Well, I already have a error. It should be Whitney U. Good there. We're going to set our alpha value for the video. So we're going to say alpha equals 0.05. And now we are off to the races. So let's take a look at example 1, which is going to be a manual calculation. So I'll say example 1 manual calc. And what we're going to take a look at is music streams for two different artists. So two artists that I listened to recently are Northlane and Alexisonfire. So we're going to go off of that approach. And we're going to say these are music streams in thousands. I don't know if these numbers are accurate or not, but regardless, that is what I'm going to be using in this video. So first, we have Northlane streams, so 565, and these are going to be in hundreds of thousands, right? So 565,000 monthly listens or something like that, right? 550, 530, 525, 543, 45, 35, 28, 60, 555, 515, and then also 540. So that's what we have on Northlane, and then let's grab Alexisonfire. And 500, 511, 505, 519, 530, 525, 520, 518, 510, 535, 30, and also 25. Awesome. All right. And what we're going to do is we're going to create a data frame based off of these NP arrays. So what we're going to say is data equals pd.dataframe. And inside over here, we're going to have a dictionary, right? So we'll say streams np.concatenate. Inside over here, we'll have both those. So we'll have Northlane streams and then Alexisonfire. So those over here. And then what I'll have next is we'll have band. So band inside over here, we'll have Northlane times the length of Northlane streams. And then we'll have is over here plus and I'll say Alexisonfire. And just do the same thing. The length, put Alexisonfire there. We should be good to go. Awesome. So just to show you what this looks like, we can just do data.head, right? And you can see streams, right? Northlane. Okay, cool. So we're good there. And what we're going to do is we're going to rank this data. That's why we're using pandas this time. It makes it easy for these ranks. So we'll say is data rank equals data streams dot rank. And then in our method, we're going to say average. So method equals average, like that. Okay. And then what we're going to do is separate the ranks for each band. So we'll have Northlane ranks equals data, that over here, data band equals Northlane. And then here we'll have rank values. Okay. And then we're going to do the same thing for Alexisonfire. So Alexisonfire. And we'll do the same thing for that. Cool. And what I'm going to do next is we're going to print this out. Print out our data. You can see streams, band, and then the rank associated with it. So all these for Northlane, all these for Alexisonfire. So we're doing good. We're doing good. Okay. So now what we need to do is we're going to have to sum up the ranks for each of these groups. So what we'll say is these are our R values. So we'll have R Northlane equals, so we'll have Northlane ranks.sum. Then we'll do the same thing for Alexisonfire. There. Great. And what we can do is print out both of these if we really wanted to. So we can do that. Print out Northlane. Should get 204.5. This is also good for me just to check I didn't have any bugs in my code. Who's already prepped this code. So Alexisonfire 95.5. Yep, that lines up with everything that I have so far. So we're doing good. Now what we need to do is the number of observations for each group. Technically, we could have done that earlier, but that's all right. We'll say those are n values, so n north lane equals length. And then I'll have in our north lane streams, And technically, you could have just defined these values earlier also, without even doing the length. Just know what they are, but it's okay. It's not a big deal. So it's there. And they're going to be the same length anyways. Okay. And now what we should do is calculate the U statistic. So we'll first do it for north lane. So U north lane equals, and this is going to be our R north lane. We're going to say that's minus inside over here, N north lane times N north lane plus 1. And then outside over here, divide by 2. That should be it. Let me just double check. R north lane minus inside over here, and north lane times N north lane plus 1, divide by 2. Yeah, that should be our U statistic for north lane. And then we're going to do the same thing for Alexis on fire. So I'm just going to copy that. And we're going to apply this to each of these over here. And again, I will show you a much quicker way to do this. But I feel to appreciate it, we always have to do the manual calculation. All right, let's print out both of these U statistics. So print out, and first we'll do north lane, right? And we get 126.5. And then let's do Alexis on fire. So print out Alexis on fire. And we get 17.5. And remember what we said in the slide is the U statistic is going to be the minimum between both of these. So we'll say U statistic equals the min. And then just pass in both of these. So like this is a super easy line of code, right? So pass in north lane, pass in Alexis on fire. And our U statistic is going to be 17.5, right? So there's that side of things. And we'll print that out. Now, if you wanted to get our p-value, we'll just run the Mann-Whitney U test with SciPy. We could also get the stat from here. But regardless, that's going to be the way to get the p-value here. So we're going to go over here and say p-value. And it's going to be equal to Mann-Whitney U. Inside over here, we'll have our north lane streams, and we'll have our Alexis on fire streams. This is technically our shortcut too, but that's all right. Alternative equals, and make sure you define what you're using. This is going to be a two-sided test. So two-sided. Oh, I misspelled streams. That's wonderful. And just to show you our p-value, so print out our p-value, in this case, right, 0.0001, which is very low. And let's just print out our interpretation. So what we do on that side of things is grab this. There you go. And it says there's a significant difference in music streams between the two bands. And yeah, our p-value is way less than alpha, which should actually define this as alpha, not 0.05. You can see super low p-value. So we reject the null hypothesis and go with the alternative one, null hypothesis over there. So yeah, we're doing pretty well on this first example. A lot of ranking, a lot of math behind it, but let me show you that shortcut for both of these. Well, I already showed it to you, but regardless, with our example that we did in the slides, right? Let me show you how quickly we could do this. So this is gonna be example two. And what we're gonna take a look at is the satisfaction scores of two different baseball card shops. So we already covered that, but let me show you how we can do this in literally essentially one line of code. So we have store one, right? We have the scores over here, 82, 85, 87, 88, 90. And then we have store two over here, 84, 86, 89, 91, and 92. All we're gonna do is we're gonna get our statistic over here, and then we're gonna grab our p-value, and that's gonna be equal to our Mann-Whitney U, and inside over here, we'll pass in store one, then we pass in store two, and then we say our alternative equals two-sided. Right, And let's print out both of those and see if we line up with what we had in those slides. So we print out our statistic first, right? We get 8, which was the lower of the two U numbers that we got for these scores or for these stores. And then if we get our p-value again over here, right? So grab our p-value and we get 0.42, which we cannot reject our null hypothesis, right? So we just paste in our if-else statement for interpretation on this, right? And I apologize for not having these as alpha. First time I prepped the code, I just put 0.05. There's no significant difference in customer satisfaction between the two stores. That's what we had on the slide deck. So pretty easy, right? You import SciPy, Mann-Whitney U, and this is a two-sided test, right? But I want to show you also that you could specify greater than or less than also with the Mann-Whitney U test, and that determines your tail direction, right? So let's compare two different baseball players on this last example. And also I wanted to show you in this last example, Shapiro for normality, because I didn't show that in example 1 or example 2. And typically when you're using Mann-Whitney U test, your distributions do not follow a normal distribution. That's why you're going with Mann-Whitney U, right? So let's take a look at example 3, tail direction. So again, there's 3 different ways you can specify, right? Two-sided, you have a left tail or right tail. So let me pass in batting averages, right? So let's say we have player X over here, and we'll go over to player Y next. So we have player X, and then let's grab it in our player Y. And these are going to be batting averages over 15 seasons, right? And what we're going to do is first run our Shapiro test. So I have a full video on it, so if you want to check it out, awesome. If not, really quick, we can just grab this in SciPy. We'll say value player X equals, we'll say Shapiro, and we'll have our player X averages. Pass that in over here. Misspelled Shapiro, that's all right. And let's print this out. So you can see over here, does not follow a normal distribution, right? The alpha value is, or this value is less than our alpha, which is 0.05. So we reject the null hypothesis. This does not follow normal distribution. I did the same for the Y when I was building out these numbers. So if we go over here to Y, and well, it should be capital Y on this one, right? And I print this out, you'll see that also fails Shapiro. Let me just go that side of things, right? 0.01, again, less than 0.05, which is our alpha defined in this video. Reject the null hypothesis. Again, does not follow a normal distribution. So what we can do is the Mann-Whitney U test. And what we can do is, again, specify. And I wanted to specify a tail direction. So I'm going to go with greater in this case. So we'll say stat, we'll have our p-value equals Mann-Whitney U, like that. Then we have our player X averages. So we have that. Then we pass in our player Y averages. Great. And we'll say our alternative is greater. And just to show you what these averages are, I didn't even check what these are. Over here. Average. I'm actually curious. So player X has 267. Player Y has 266. Okay. So they're pretty close. So we're going to look at greater. And what we're going to do now is we ran the Mann-Whitney U. And let's just print out our p-value. That's what we're going to be taking a look at. And it's 0.131. So we can't reject our null hypothesis in this case. And I mean, even taking a look at these, right? 266 versus 267, they're close. So we know there is no significant difference between the batting averages between the two players. So hopefully you guys learned something new in this video with Mann-Whitney U and how you can implement it in Python. Again, that first example is a manual calculation. I really don't expect you to do this manual calculation. I kind of just like it for these videos. I'll show you step by step. So we always can appreciate SciPy. Typically, you're going to use two-sided if you're just looking for the difference. But then again, based off of your tail direction, if you want to do a one-sided, you have those options, right? Greater than or less than. And if you want to test if those distributions are normal or not, run Shapiro, right? Pretty easy, one line of code. And yeah, that's essentially the Mann-Whitney U test in Python. So that's a tutorial on the Mann-Whitney U test. And if you guys found some value in this video, make sure to subscribe to the channel. We're uploading at least 3 different data science focused videos every single week. Now, this video had to focus on statistics. And if you want to continue learning on that side of things, I have a few videos linked down below in the description. And I have a playlist right over here that you guys should check out.